Another pair of simultaneous equations to solve. So off you go. Pause the video, solve it. See what you come up with, and then look and see if what you did is what I did. Got stuck in, you had to go. It's really important. You try. Now, what's the process? Let's look at the process. What do? We label. First thing we want to be doing is labeling the equations. So I'm going to have equation 1 and equation 2. And then we want to cancel, we want to eliminate one of the letters. You can only find one unknown at a time. So it's either I'm going to find X or I'm going to find Y. And in general, I tend most of the times to go for eliminating X and finding Y first. Okay. And I run into a bit of a problem here based on the work we've been doing before. And maybe you've run into a problem as well. Because I'm thinking, well, I don't have the same number of y's to get rid of the y's. I don't have the same number of x's to eliminate the x's. But then when I start, let's say I take equation 1 and I multiply equation 1 by 2. Well, then I'm going to get 4x plus 6y. I still don't have the same number of x's. I still don't have the same number of y's. Well, the y's I'm getting even more now. And then okay, 2 doesn't work. What am I supposed to do? If I multiply by 3, multiply everything by 3, I get 6x plus 9y, and yeah, and I'm going to get a 14. The 14 has to be multiplied by 3 as well. Let me just make that clear. But I'm just thinking about the x and y's because I want to be able to eliminate x's and eliminate y, or eliminate y's. And it doesn't work. I'm not, because I'm going up into 2 times tables, I can't get the same number of, I can't get 5 x's. It's not going to happen. Because I'm going up, if I look at equation 2, if I was to double equation 2 or treble equation 2, I'm not going to get the same number of y's. As soon as I double it, I get 4y. So it's not going to work out. This is a situation where you have no letter, you have no unknown that can cancel out, be eliminated without doing any addition or doing any multiplication. And you cannot do one multiplication to get to a situation where the unknown can be eliminated. You cannot do one multiplication. In cases like this, you need to do 2 multiplications. So that's the additional difficulty coming up here. So what would I do? And the strategy I use, instead of wondering what should I multiply the first equation y by, what should I multiply the second equation by, well, I use the coefficients, and that's what I'll recommend, the coefficients of x. Say eliminate x's. If you wanted to eliminate y's, you'll use the coefficients of y. Coefficient is the number in front of the letter. So I'm thinking about the 5. And I'm going to just and in equation 1 I have 2 x's, in equation 2 I have 5 x's. Just swap around the coefficients and multiply it, and you sort it. What do I mean by that? 2 is the coefficient, the number in front of x in equation 1. So I'm going to multiply equation 2 by 2. 5 is the coefficient of x, the number in front of x. So I'm going to multiply equation 1 by 5. Equation 1 gets multiplied by the 2 equation. Sorry, equation 1 gets multiplied by the, what am I saying? Equation 2 gets multiplied by 2. Equation, and I'll just put a little 2 here. Equation 1 gets multiplied by 5. And do you see what happens? Yeah, we're back in business. If I multiply every term in equation 1 by 5, then I will get 10x. Why am I putting in blue? I need to stick with red. So I now have 10x, and then the 3 has to be, so we're multiplying by 5, multiplying by 5, multiplying by 5. That will give me 5 3s are 15, so plus 15y. And then 14 times 5, that will give me 70. So 70, and that will be my equation 3. 10x plus 15y is equal to 70. Similarly, now if I multiply equation 2, multiply throughout by 2. So the 5x by 2, you see, double 5x, you get 10x. Now I have the same number of x's. That's what we wanted. We can now eliminate x. We're in game. We are in the game. And then I multiply 2y by 2. That will give me plus 4y. And then the 24 gets multiplied by 2. So that will give me double 24 will give me 48. And we'll call it equation 4. That's what we wanted. That's what the strategy of multiplying the first equation by the coefficient of x in the second equation and multiplying the second equation by the coefficient of x in the first equation. Swapping around coefficients to use as multipliers. 2 multiplied by 2 the second equation. 5 multiplied by 5 the first equation. So, and it works. Now we're back to what we were doing before. That's the new idea. This is the new idea. I've just gone through it, and hopefully it makes sense. We'll finish the job now. Or if you didn't know how to, if you weren't able, if you didn't get to this stage, what is going on with me? I'm happy. That's what's going on. Right. Finish the question. If you didn't get to this stage, you weren't sure where to go, now you should be able to finish this question based on the work we did a couple sessions before. So off you go. Off you go. You power pause and you finished, and now it's a chance for me to do it, and we'll see if we did the same thing. I'm doing the subtraction. I already set that up. That means that the x's will cancel out. 10x take away 10x gives me 0, and minus and plus is a minus. So I got 15 take away 4, 15y take away 4y, which will give me 11y, and then the 70 take away 48, and 70 take away 48. Oh, nice, lovely. It gives me 22. So what we have is that y is equal to 2. After we have the value of y, what do? We substitute y equals 2 in equation. Which one is easier? We'll go with equation 1. We'll do our checks in equation 2. Did you do your checks? Are you sure you're right? If you're absolutely sure, you can skip the video a little bit and move on to the next problem. You know, if you're doing your checks. If you're not doing the checks, then I'm not totally happy. I'll be honest, I'm not totally happy if you're not doing the checks. You want to get in the habit of doing the checks, okay? So substituting y equals 2 in 1, we will end up with 2 times, whoa, I was going to substitute it in x. So 2x, and I'm going to put it in a different color. That's what I'm going to do. So I'm going to get 2x plus 3 times 2 is equal to 14, which means that 2x plus 6 is equal to 14, and that means that 2x is equal to 8 and x is equal to 4. I've skipped because I'm going to do 14 take away 6. That's where I'm getting the 8. X is equal to 4. So that's my second solution there, and I'm going to substitute those two values. I'm going to do my check in equation 2. So I'm just going to write it down, check. Put it at the top here in 2, and in equation 2 where I have 5x is going to be 5 times 4, which is 20, plus 2y. It works. 2 times 2 equals 24. So yeah, we are fine. So that more complex double multiplication, 2 multiplications have to be done before you get to the point where you can eliminate the variable. And I go for the x's. You might want to go for the y's. You might see something I might not have seen, but I love to just eliminate x, find y. It works for me. Let's do another one. Yeah. Here you go. I call this one P0. I didn't call it E1. I called it P0 because I want you to have a chance to try and do it for yourself. So off you go. Go on. Right, shall we? You had your chance. You did your pause. Power of the pause. You pressed the button and it's like, I can do this. And you just got stuck in. And the first thing you did, because I'm going to do it now, I'm going to label up the equations. Equation 1, equation 2. Don't let the negatives scare you or anything like that. We're going to stick with that strategy I gave you. And what's the strategy? I look at what's the coefficient. In equation 1, the coefficient of x is 3. So I'm going to multiply equation I'm going to multiply equation 2 by 3. And I'm going to change the rule for equation 1 slightly. You'll understand. The coefficient of x in equation 2 is minus 4. I could multiply by minus 4, but you know what? I'm just going to multiply by 4. We'll get the same place. If you multiply by minus 4, you'll get the same place. It's just, do I really want to minus by a negative number? Not really. But that might come back to haunt me. We'll see. So that's the multiplication I'm going to go with. And in terms of the positive values, and I pause because I want you to get on. You do it. Don't wait on me. You start. If you weren't sure what the multiplications were, I've shown you what multiplications I'm doing. Off you go. Come on. Just get on. Stuck in. See what happens. I am going to do it now. I'm going to multiply each term by 4, by 4, by 4, by 4. That's equation 1. And I'll get 4 3s at 12. X plus 5 4s are 20. That is a multiplication sign. So 20y, and then 4 2s are 8, so equals to 8, and I will call that equation 3. In terms of equation 4, what do we have? We're going to multiply equation 2 by 3, which means that the minus 4x needs to be multiplied by 3, the 7y needs to be multiplied by 3, and the minus 30 needs to be multiplied by 3. That will give me minus 12x. We're going to deal with how we deal with that minus, but you can see what's happening. We now ignore the minus sign for a moment. We'll see how that we deal with that, but we have the same. If we just think about the positive values of the coefficients, they're the same. 12x, 12x. 7 3s, that's 21 plus 21y, and then minus 30 times 3, that's going to give me minus 90. Minus 90 is what we're going to have there. And I will call this equation 4. I'll label it as equation 4. And you'll see, if you went with minus 4, that's fine. We will get the same answer. You would have had the negative 12x, negative 20, negative 8, and you'll see we'll get there. We'll get there. What am I supposed to do now? What would happen if the default, and you might be used, and you might be thinking that, hey, you need to subtract equation 3, take away equation 4. But hang on. A minus and a minus gives a plus. If you were to subtract equation 4 from equation 3, you're going to end up in hot water because you'll have 24x. And the whole point, what are we doing this for? We were doing this because we need to eliminate the x so that we can find y. Subtraction is not going to work. We need to make this an addition problem. That's what we have to do. Did I just say that? Yeah, you gotta have a bit of style there, you know. Not proper English. Make sure you speak proper English, please. Thank you very much. A plus and a minus will make a minus. Whoa, don't scratch off the number. Whoa, 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 whoa. Okay, I don't know what happened there. Right, okay, let's do this. We're going to do our subtraction now, and I should make this a little bit prettier. Looking for some colors here. I'm just going to put a line there, you know, make it... Oh, it was supposed to be a straight line, but you get me. Right. I'm doing the subtraction. I got 12x minus 12x. That's plus and a minus makes a minus. So the x's are gone. And then I got 20y plus 21y. And 20 plus 21 is going to give me 41y. And then we have 8 plus minus 90, which is going to be 8 take away 90. 8 take away 90. And I'm just thinking, well, what's the difference between 8 and 90? And that is going to be, that's going to be 82. So what we're going to have here is minus 82. We know the answer is going to be negative. Just think about the difference and then put in the sign. So the 8 plus minus 90, that's going to give me minus 82. Now, if 41y is equal to minus 82, then y is going to be minus 82 divided by 41, y is going to be equal to 2. So we have the value of y is equal to 2. Wasn't that scary after all? Am I right? No, I made a mistake. What's the mistake I've made? Absolutely right. I'm supposed to say y is equal to minus 2. Thank you very much. I divided a negative number by a positive number. So y is equal to minus 2. Now we need to substitute. I'm going to sub y equals minus 2 in equation 1. I don't really want to have to even check in equation 2, to be honest, but I got to do my duty. So we're subbing minus 2, and that means that we have 3x plus 5 multiplied by minus 2 is going to give us 2. That would say that 3x, we're substituting equation 1. That's what I pulled at 3 times x plus 5y equals 2. So 3x minus 10 is equal to 2. That means that 3x, wait a minute, what did I do? That's not minus 10. There's a positive sign in front there. What is up with you, sir? Plus minus 10, and the positive and the negative make a negative. So it's 3x take away 10 equals 2. That means that 3x is equal to 12. The minus 10 goes on the other side, and it becomes positive. So 3x equals 12, and that means we have x is equal to 4. So the value of x is equal to 4. So we got 4, we got y equals minus 2. That is the answer. The answer we're going with, let me just put it in a lovely box here. Okay, the box might not be that lovely, but We're getting in there. Whoa, that's what I was trying to avoid. I'm cramped at the bottom of the screen, aren't I? Ooh, ooh. Oh, stop moving. What's going on with this thing? It's not. Oh, let me just put it in. We're saying x equals 4. We're saying that y is equal to -2. We're going to check that. Check. Check. Make the check. I'm going to put the check up there. I'm going to write it in as check. We're going to do the check. And the checking in 2. So check in 2. I have -4, really. -4 times 4. That's going to give me -16. Plus 7 times -2. This is hard. We get -16, and then that, oh, okay, right, it works. 7 times -2 is -14, so positive plus the -14 is take away 14, which is the -30 as required. I had to go outside of my red box. That means I need to make the red box longer. That's what we're talking about. And yeah, we checked, it works. That's your solution. The value of x is 4. The value of y is -2. Thank you very much. Now, I've worked hard. I've worked really, really, really hard. It's time for you to work hard. You can get a whole problem set to work on. Because this, I'll tell you, you see this topic, this simultaneous equation thing, it is super, super, super important. You're going to use this technique, solving simultaneous equations, right through into advanced maths. So you need to nail this, all right? You need a lot of practice and drill to just master this. And that's what we're going to do next. So here you go. 3 problems to solve. Press the pause button and you see what you can come up with, okay? Don't be surprised if you get some surprises. That's just all I'll say for now. Off you go. Off you go. Right. Okay. Number 1 and number 2 should have been normal, and then number 3, I'll give you a hint, just in case you haven't done it or you're feeling, before I actually go to answers. The answers are right on the other slide. I just wanted to point out that for number 3, if I look at the y's, the order has changed. So really what you want to be thinking about number 3 as a hint is that 3x plus 2y is equal to 8. That is your equation 1. But in terms of equation 2, it's probably better to write it as -5x plus 2y is equal to 8. And then, if you rewrite it like this, isn't that an easy question? Just look carefully at it. It's one of those interesting things. You see what I'm seeing? Okay, right. You had your moment. We're going to give the answers for 1 and 2, but I think 3 was the more interesting one in my view. I have 2y equals 8. I have 2y equals 8 in equation 2. The only difference in each of the equations is the number of x's. And think about it. If I'm going to get 8 and I already have 2 y's, is it possible? What can x possibly be? Because if x is 1, I'm going to get 3 for 3x, but then I'll get -5 below, and it's just not going to work because I have the same amount of y's. What it means when you look at this is that, what's that telling me? That means the only way this can work is if x is equal to 0. Yeah, it's one of those. And the answer is for all 3 now. Think about what I said there. You had to rearrange, but then you had to realize, well, the same number of y's, same output. The only way is if the x's are 0, and 0 is allowed. Just as fractions and decimals are allowed as well. And I'm saying that you know what's going to come up in a bit, aren't you? Right, so these are the solutions that you should have for question number 1, 2, and 3. And now let us look at, let's do 3 more. We'll do 3 more. Chuck in a word problem here, there. You know, that's how we can do it. So here are 3 other questions for you to try. You've had the answers. You have 3 new ones. Here are 3 new ones for you to try. Question 4, 5, and 6. Negative numbers are going to come in. Fractions are going to come in. Be okay. You can get a fractional answer. I just want to throw that out there. Fractions are okay. Right. You've had the chance, power the pause to do it. I just want, just in case number six was an issue, a special for number six. Number five is special. Did you try number five? Was it special? You know, you can I just say you can use a calculator? You can use a calculator, okay? I'm fine. I'm no issues with the calculator. It might help. Follow the strategy, the methods, but when the numbers get ugly, expect it to be on a calculator paper. So calculator allowed if that was a barrier to you doing the work. For number six, the difference here, we have equals equals zero equals zero equals zero, but well, hey, the constant, the number all by itself, is a bit different to what we've been doing before. It's all it's on the left hand side. You need move it over to the right. -1, move it over to the right, and then you're back to what we've been dealing with before. So you should have been thinking about x 7x take away y is equal to -23, and then x plus 2y is equal to +1. So those would be your equations there. You need to rearrange the equations, and then it becomes to what we were doing before. That's the way I would do it. I mean, you might want to stick with it as is. And hey, if you're okay with that, that's fine. There are other methods, a substitution method for solving simultaneous equations. I haven't gone through it. We'll focus on the elimination method, but there are other ways to do this. One day you'll see it. So if you were stuck on 6, you have a way forward there. If you've gone through, let's just see, what should your answers be for 4, 5, 6? 5 was beautiful, wasn't it? Those are the answers you should have. Negative numbers for number 4, -3 and -1. For numbers 5, fractions, 46 on 43, -13 on 43. Did you get that? Ugly stuff to work with, but with a calculator, hopefully that made it easier. And then for number 6, -3 and 2. -3 and 2 are the solutions you should have. Now, what would looking at simultaneous equations be if we didn't have at least one word problem? Come on, come on. Here you go, here you go. Have a read. Form and solve the pair of simultaneous equations. Form and solve. That's what you're doing there. Pause. Use the power to pause and you work through this one. Let me see what you come up with. Come on, you can have success. You can. Yes, you can. Do it. Do it. All right, before I get the answer, let's just put together the yeah, okay, fine. We'll put together what the equation should be, where you think you're assorted. You think you're assorted? You ready? We had what we're talking about. Cost of flour is X. We were told what the variables would be, and the cost of sugar is Y. So sugar, the cost of sugar is Y. Cost per kilo, really important. So the first equation you should have coming out of this is based on the 850 that's being spent on sugar and flour for 5 kilos. So if X is the cost of flour per kilo, then I'll have 5X. And then I add the cost per sugar per kilo, 3Y, then you're going to get 850. That's the first equation you would want to have. And then the second equation, it's based on 1320. You're buying different amounts. This time you're buying 8 kilos of flour, so 8X, and 4 kilos of sugar, so 4Y. Those are the two equations you should have been building from. Then you're using the methods that we went through. If you didn't do it, if forming the equations were an issue, we've resolved that. Off you go, make it happen. Answers are coming up in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, right. Here you go. These are the answers that you should have had. X, £1.40 for a pound of flour, and 50p for a kilo, and 50p for a kilo of sugar. And at this stage, I'm thinking, and I hope you're feeling, simultaneous equations, linear equations. Let's be careful. There's another type that's going to come at a different stage, but simultaneous linear equations, yeah, I got that. Thank you very much.